So here, good morning, my dear students. Welcome to Zoom online class. Students, here, this is your chemistry period. So just take out your chemistry book. Chemistry book. I hope you all are already ready. So here, students, just take out your book and that uh, turn piece number 44. Students, just take piece number 44. Piece number 44. Here, students, properties of matter in different states. In previous class, we have studied about properties of solid. What that solid have definite shape and volume, solids are incompressible, solids have high density, solids do not diffuse. Now, today we are going to study about properties of liquid, and properties of gases. Let's see how much we can able to cover. So here, first properties of liquid. Now here in this first property, liquids do not have a definite shape but have a definite volume. Usually students, liquid do not have definite shape. If you see the liquid, it does not have any shape. Or you can see milk, water, or any drink. It does not have any particular shape. Always it takes the shape of container in which it is being kept. So here just what is given here, just see. In a liquid, the molecules are loosely packed. See, molecules are little bit far away from each other. This allows the movement of molecules and they are free to move around and slide, slip and glide over one another. Hence, liquid do not have definite shape. Students, in case of liquid, suppose this is liquid molecules like this. Liquid molecules are far away from each other. They are far away. And because of this, what happened? These liquids are easily moved since there is sufficient intermolecular space. Here also, here is a sufficient intermolecular space. So these liquids can easily move wherever available space. They will easily move. They will glide, they will slide, they will move, they will collide. Means everything, whatever they want, they can do. So hence, what we can say, liquid do not have definite shape. They take the shape of container they are put in. Though liquid do not have definite shape, they take up a definite amount of space in a container. Hence, they have a definite volume. No, it does not have definite shape. Okay, but in any container, if you keep, it will take its shape. Means its shape means definite to definite level. It will be at a definite level. So what we can say, it will remain at definite level. So what we can say, that a liquid does not have definite shape but have definite volume. Why not having definite shape? Because there's sufficient intermolecular space and they can easily move in that one. They can collide, they can slide, they can move, and hence they does not contain any particular fixed shape. But since molecules will remain within certain limit, hence they are having definite volume. Now, activity 3. What is given? Aim to show that liquids have a definite volume but no definite shape. Material requires water, a beaker, a conical flask, flat bottom flask, a measuring cylinder, water. Now, what is given? Process is method. What are the methods? Now, first, measure 20 ml of measuring cylinder. Means what is, just for simple example? Here, see, just look here. A flat bottom flask is here, conical flask in beaker. Now, if this liquid, we keep this liquid in a beaker, like here, if you put this liquid in a beaker, this will take a particular shape. This will take the shape of that beaker. Water will take the shape of beaker. if you will put that one in a bowl, no, then it will take the shape of that bowl. Or if we take a conical flask like this, a conical flask like this, no, it will take the shape of a conical flask. No, here it will take the shape. No, so that is given here. Let measure 200 ml of water in a measuring cylinder. Measure 200 ml water. No, pour this water in flat bottom flask. No, then pour that one in conical flask. Then pour that one in um, beaker. No, then what you will absorb? What you will absorb that the volume of water all the three containers is the same. Volume will remain same. It will be 200 ml only. No, but no, but each time water take the shape of container in which it is poured. No, so either if you put water in a flask or in a glass or in a bowl or in a conical flask or flat bottom flask or round bottom flask, every time the water quantity no will remain same, but its shape will change. So conclusion that this proves that liquid do not have definite shape of their own, but they have a definite volume. Do not have definite shape, but have a definite volume. Now, next is liquid have a tendency to flow. That is fluidity. It will able to flow. A liquid generally flows because its molecules are able to slip, glide one over due to weak intermolecular force of attraction. Since intermolecular force of attraction is weak, no, hence this molecules are able to slide, slip, glide all over, and hence it can able to flow. Next, liquid cannot be compressed much. No, see students, in case of liquid, no, as we know that intermolecular space is little bit, means not too much as compared to gas, but it is little more as compared to liquid. So here in this case, here is a space, here is intermolecular space, here is no, since this I have intermolecular space, when we come when we give force on it, pressure on it, no, then what happened, these molecules will come close to each other, no, come close to each other. So we can say it is slightly compressible, not fully compressed, it is slightly compressible. So that is given here that in liquid, though the molecules are still quite close together, the spaces between are more than those between the molecules of solid. Therefore, liquids are compressible or liquid or little means little bit we can able to compress. Next is here, liquids have less density as compared to solid. It is having less density as compared to solid. So that is given here that liquid have more intermolecular force of intermolecular space as compared to solid. No, as in case of solid, intermolecular space is more. No, hence liquids have less density as compared to solids, because here in this case, if you see the solids number will more. No, but in case of liquids, its number will less dense. Meaning kam ghana hai. No, it is less dense, but in case of solids, they are more dense. Now, liquids can diffuse. No, diffuse means intermix, we can say. In liquid, the intermolecular force of attraction is weaker than that in solids. So molecules in liquid can diffuse and mix one another. No. So if you take a glass of water and if you put 2 drops of ink in it, 2 drops of ink, what you will find that ink, that is blue ink, no, that blue ink easily mix with water. You will find that now after some time, color of water will become blue. No, why? Because of ink, mixing of ink in water. No, that is given here that liquids have more. In liquid, the intermolecular force of attraction is weaker than that of solid. So the molecules in liquid can diffuse and mix with one another, For example, if you drop a bit of ink in a beaker of water, the ink will spread slowly through the water. Now, ink or any other substances means liquid only, that liquid easily mix with other substances, no, means other part of water. Now here, get it right, just see what is given. Uh, Generally, it is said that only liquids are fluid. Generally, we are telling that liquids are fluid. However, fluids are substances that can flow. What is fluid? Fluid are those substances that can flow, that move from one place to another. Means it flows from high level to low level. Sometimes, and if level is same, little bit move. Therefore, not only liquid but also gases are called fluids. So, what we can say, liquid, not only liquid, gases are also called fluids. So, both liquid and gases are fluids. Solids are not fluid, but in case of liquid and gases, both are fluids. Now, properties of gases. Now, students, here our next topic is properties of gases. What is given here? Gases have neither a definite shape nor definite volume. In case of solids, solids are having definite shape, definite volume, both things. In case of liquids, liquids have definite volume but no definite shape. But in case of gases, gases does not have both things. No, that is neither. They does not have a definite shape nor volume. Neither volume nor shape. So that is given here. That the intermolecular space of gases is maximum, and there is negligible intermolecular force of attraction. So the molecules move freely around in a closed container and fill the entire space, irrespective of its shape or size. Thus, gases take the shape and volume of the container they occupy. No, means irrespective of whatever shape, gases does not have any shape. No, so irrespective of any shape of container, and when you fill gas in any container, it will take the entire space available for them. No, for example, simple example, if you burn instant stick, no, when instant stick, agarbatti, no, you burn at one corner of your room, no, what you will find that after some time you will find smell at another corner of the room. Why? Because when they produce this instant stick burn, it produces smoke, and the smoke is gas, and gas will spread all over this room, and that is what, that is gases of molecules of gases. No, and that will occupy the entire space available for them. Now, next is gases have maximum fluidity or capacity to flow. Gases can flow maximum. So that is given here. Since the molecules of gases are about to move freely, they flow easily. Gases of molecules, no, molecules of gases, there's sufficient space. The intermolecular space is sufficient. Intermolecular force is less or negligible, so they can easily flow. Sorry. Gases are highly compressible. No, we can easily compress gases. Since there's lot of empty space between the molecules of gases, they can easily compress. No, in case of gases, see here, in case of gases molecule, there is sufficient space. No, here is one molecule, here is one molecule, and here's one molecule. No, there's sufficient space. So when we put pressure on this gas molecule, it can occupy, it can easily be compressible. No? So that is here what we can say, that gases are highly compressible. For example, no, a large amount of liquids, liquefied petroleum gas and compressed natural gas, that is LPG, liquefied petroleum gas, and CNG, compressed natural gas are compressed and put inside relatively small container for our use. No, students, we are at our home. We are using the LPG, liquefied petroleum gas. No, so that gas is what? That gas, large quantity of gas is being compressed in a small container, this whatever liter, no, that in cylinder, and compressed, it is in compressed form, that gas is in compressed form, and that it is used for burning purpose, for as a fuel. So students, here this is about properties of gases. In next class I will continue the properties. Here Harshita Singh is raising hand. Let me ask what is her problem. Harshita, from that time she's been. Harshita,
Yes, ma'am.
yes, but
Ma'am,
any doubt?
yes, ma'am.
Mm-hmm.
Ma'am, in liquid property, the third one.
In liquid property, third one, liquids cannot be compressed much. This one, no.
Yes.
Okay, beta. Okay. See, in case of liquids, what happened? There are molecules. There is molecules. There are molecules, and the intermolecular space is is more as compared to solid. No, means there's intermolecular space. Here is see here in this case there's intermolecular space. Here's little intermolecular space. Here is. No, so when we will compress them, when we'll give force on this one, when we'll give force, then what happens? These molecules will come closer. Now see here, when we decrease the surface area, no, then what happens? These molecules will come closer to each other, no, and hence it can be slightly compressible, slightly, not fully, slightly compressible. Okay,
Okay.
compressible. Okay, Vita. Now here. Aradhya Tiwari. Aradhya, Aradhya.
Good morning, ma'am.
Yes,
Good
good
morning,
morning,
ma'am.
Beta. Any doubt?
Yes, ma'am.
Ask.
Ma'am, liquid second.
Liquids, properties of liquid.
Yes, ma'am.
Properties of liquid, you are asking.
Yes, ma'am.
Properties of liquid. Liquids have a tendency to flow. No, if you put liquid anywhere, it can easily flow. Have you seen? No, it can easily flow. So why it flows? It flows because molecules, we are given no, that there's sufficient intermolecular space. See, here is the intermolecular space. No, so when you will put liquid or if you keep liquid anywhere, the molecules can easily move. It can move here, it can move here, it can move here. No, and they will collide, they will slide, they will move. No, and hence because of that, they show movement. No, so it flows. Means movement means flows. No, hence it is called fluid. It is a fluid. Liquid is a fluid since it can easily move. No, from high level to lower level. Okay.
Okay, ma'am.
Okay, Vitam. Yes, Aradhya Garima. Garima.
Yes, ma'am. Ma'am, I have doubt that why gases are also called fluids.
Yes, gases are also called fluid because they can easily flow. No, when you keep gases, no, it will easily flow it can easily move from one place to another. No, and that is given here. No, that generally it is said that only liquid can flow, but however, gases can also flow. Why? Because its molecules move from one place to another. When you keep instead, for example, if you burn incense stick or if you use perfume, what you will find that the person standing nearby you, they can also able to smell, no, that fragrance of perfume. Why? Because molecules can easily move. Molecules of gases can easily move from one place to another place. No, means one reason to another reason. So they can able to smell the fragrance of perfume. Hence, we can say that molecules of gases are also coming category of fluid. Okay.
Okay, ma'am. Thank
Okay,
you.
beta. Okay. So students, your time is over. No. Now be ready for your next class. So your Zoom live class, chemistry Zoom live class is over, and your homework is to read the properties of liquid and two and three properties of gases. Okay, thanks for your participation.